Hello and welcome to our presentation. We are going to speak about thermodynamic and exergy analysis of Damovan combined cycle power plant. I am Mohammad Farajinejad and my friend Ali Reza Zourifar. Here we can see the contents which include introduction, description of a studied system, conclusion and references.
Combined cycle power plant is used to generate electricity. Most of the time, it is also termed as the combined power gas turbine. This kind of power plant have significant advantages. First of all, it has high overall plant efficiency. We can attain 50% efficiency. And the next advantage is about environment. The amount of cooling water that you use for this power plant is about 50% as much as for a steam plant. Moreover, very low nitrogen oxide level is another attractive features. For talking about this cycle, we need to know Carnot cycle. Carnot cycle is defined as an ideal reversible closed thermodynamic cycle. In this cycle, a system or engine transfer energy in the form of heat between thermal reservoirs at the temperature Th and Tc. And also this process work to convert heat to work. I mean that we can create work by convert heat to work. And this process has four stages. First, a reversible isothermal that transfer QS from a hot reservoirs to the float. And the next is a reversible adiabatic gas expansion process that does work in turbine. And the next one is a reversible isothermal process in which heat is transferred from the float to the cool reservoirs. And finally, a compression reversible adiabatic process that increases flow pressure. Also, we should talk about a Rankine cycle. This cycle consists of four steps. At the first, low pressure water is converted to the high pressure water by using pump. And the water is transferred to the boiler in an isentropic process. After that, the water temperature is raised by transfer heat from a hot reservoir in the isothermal process. And after that, superheated steam exists from the boiler in expanded after passing through the turbine. And this expansion leads to work through the turbine in the isentropic process. And finally, the heat is absorbed in the condenser in the isothermal process.
Okay, here we can see Damovan combined cycle power plant specification. This table shows some of the features of this power plant. The number of gas units are 12 and the capacity of each gas unit is 145 megawatt and the number of steam units are 6 and the capacity of each steam unit is 160 megawatt and the combined efficiency is between 50 until 55%. I'm going to speak about the schematic of gas cycle and a table which indicates some features such as inlet and outlet pressure and temperature of turbine and fuel required for the combustion chamber. As we can see in the schematic of gas cycle, the inlet air goes in the compressor and compress, and after that it can go to the combustion chamber, and the temperature required for doing work in the turbine is obtained after entering the results of the previous step into the combustion chamber. Finally, the temperature of combustion products can be used for converting water to steam in the steam turbine. Here I'm going to speak about the schematic of a steam turbine and a diagram which indicates the performance or working rate in different pressure ratios. And also I'm going to speak about how we can change the pressure ratio of a steam turbine. We can change the pressure ratio of the steam turbine by changing the pressure of the extraction steam by using a hydraulic valve. And by choosing the best pressure ratio, which is 0.0994, we can have the best performance and the best working rate. And also by doing this, we can achieve lower maintenance cost related to steam turbines blade. We can protect the steam turbine blades by choosing the best pressure ratio. And also I have to tell you more about this diagram. The number one is associated with the time before reheating, and the numbers 2 to 7 indicates turbines performance after applying changes in the reheat cycle.
In this slide, I'm going to analyze exergy. And we know that exergy is the maximum amount of useful work that is done in a system. Exergy formula for turbine is shown in equation 1. Also, we can calculate delta S from equation 2. As we mentioned in previous slide, and according experimental data, the best result will be obtained in pressure ratio of 0.099. That is a ratio of extract pressure to input pressure. So in this case, we have maximum ratio of output pressure to input pressure in all cases. So according equation 2, we have the minimum amount of delta S, and also we have maximum amount of exergy in all cases, which is our final goal.
I'm going to speak about the conclusion part. It is vital for us to optimizing the efficiency of different equipment in the industry to protect the environment and lower the fuel consumption. In this project, the maximum output performance of the steam turbine is obtained in a pressure ratio of 0.0994. And in this situation, by choosing the best pressure ratio, we can have the best performance and the best efficiency. And we can have higher generation and lower fuel consumption. And also we can decrease the maintenance costs by protecting the steam turbines blades. Thank you for your time and your attention.